40 kilometers behind Russian lines, a long fuel convoy moves through what Moscow believes is safe territory. 12 rail cars carrying 120 tons of aviation fuel and diesel. The engineer thinks it's just another night run. He doesn't know Ukrainian drone operators have tracked this exact train for 84 hours, mapping every turn, every bridge, every minute of its schedule. In 73 seconds, his routine supply mission will turn into a masterclass in modern asymmetric warfare, and in how underestimating your enemy can lose a war. The strike team consists of 6 Ukrainian-built FP-5 quadcopters, 2 modified reconnaissance drones, and 4 operators who have practiced this exact mission hundreds of times in simulation. But simulations never capture what happens when Russian electronic warfare systems flood the sky with interference, blinding your control links and jamming your GPS. Standard doctrine says these FPV drones can't fly farther than 8 kilometers. Tonight, these operators will prove doctrine wrong by 5 times that distance. The area ahead is one of the most heavily defended corridors in western Russia, layered with overlapping coverage from Panzer S-1 air defense systems, Kosta early warning radars, and mobile electronic warfare trucks. On paper, nothing should get through. Ukrainian intelligence knows that, and they're betting everything on the plan they built to defeat it. High above the darkness, a modified DJI Mavic 3 reconnaissance drone holds at 4,000 meters. Its thermal sensors sweep the landscape, identifying 12 heat signatures, each fuel car glowing faintly against the cold May night. Encrypted through Starlink, the live feed travels to a hardened bunker 40 kilometers away. The Ukrainian pilots see everything. The Russians see nothing. Then, the first warning hits. A Pole 21 jammer activates along the railway, flooding the electromagnetic spectrum. Within seconds, Ukrainian video feeds dissolve into static, and GPS locks vanish completely. For 5 terrifying seconds, the drones are blind, racing at 140 kilometers per hour toward a target they can no longer see. But the engineers who built these aircraft planned for this moment. Each FPV carries triple redundant navigation, GPS when it works, inertial measurement when it doesn't, and terrain mapping data preloaded before takeoff. When satellites go silent, physics takes over. Gyroscopes measure acceleration, internal compasses calculate direction, and the drones keep flying, guided only by math. The lead pilot switches to thermal mode. Through the static, faint heat from the railway tracks forms a glowing line through the darkness, a path no jammer can hide. 3 kilometers out, the Russian defensive bubble tightens. Another jammer activates. Sensors flicker, but the drones no longer need external data. Each one already knows the terrain, every bridge, every power line, every rise and dip. At 0314 hours, Russian radar operators detect multiple unknown targets. A Panzer S-1 battery locks on. Its computer calculates intercept vectors. Then something impossible happens. The radar sees 4 contacts instead of 1. Ukrainian countermeasures broadcast false radar echoes, making 1 drone appear as 4. The Russian gunner hesitates for 3 seconds. And that hesitation is fatal. The FPVs drop to 15 meters, slipping below radar into ground clutter. The train engineer finally receives a warning. Hostile drones inbound. 90 seconds to contact. He pushes the throttle forward, but 900 tons of steel doesn't accelerate fast enough. From the bunker, the Ukrainian pilots count down through flickering video. 15 seconds, 10. Then a new threat. A Su-25 attack jet scrambles from a nearby airfield, racing in at treetop level. Its pilot spots the incoming drones at 3 kilometers. He toggles to his 30mm cannon, perfect weapon for soft targets. But instead of dodging, the Ukrainian pilots push their throttles to maximum. Batteries drain, motors scream, and the drones accelerate straight toward the train. The sudden burst throws off the jet's aim. By the time he fires, the rounds pass just overhead. At 3:16:22, the lead drone dives. Through the static, the operator locks onto the third car, carrying aviation fuel, not diesel. The shaped charge warhead detonates with surgical precision. A copper liner collapses inward at 8,000 meters per second, punching through 15 millimeters of steel. Temperature spikes beyond 3,000 degrees. 73 tons of kerosene flash vaporize before igniting. A fireball expands at 2,000 meters per second. Shockwaves tear through the ventilation lines linking the cars. Within 8 seconds, cars 2 and 4 ignite. 15 seconds later, number 5 catches fire from radiant heat alone. The second FPV dives through smoke and turbulence to strike car 8. The third disappears into black smoke, flying blind for 6 seconds, then slams into car 11. The fourth drone runs out of battery at 150 meters and still crashes into the locomotive, its lithium battery igniting at 1200 degrees Celsius. By 3:19, the entire convoy burns like a refinery. Steel rails twist under the heat. Every Russian logistics officer now recalculates what safe distance means. If Ukrainian drones can strike 40 kilometers behind the front today, they can reach 100 tomorrow. Fuel depots, ammo dumps, command posts, none are safe anymore. This is modern warfare, where a teenager with a modified hobby drone can destroy $1 million in assets from 40 kilometers away, where electronic warfare systems worth fortunes can be outsmarted by physics older than radio. At 3:47, the Ukrainian operators pack their gear and relocate. The mission is over, and somewhere deep in another bunker, new maps are already on the table. New routes, new coordinates, new trains to hunt. Because in this war, victory doesn't belong to whoever has the biggest army. It belongs to those who use what they have, the smartest way possible.